standards. NS stands for the number system, and the 1 is just designated for continuing through the number system. There's probably going to be about 2 or 3 standards that we're going to be covering throughout the year. So it's a very wordy looking paragraph. My job today is going to be going through a series of problems that will help to explain what all those words mean. A couple of terms that I'd like you to know. Maybe you could pause the video right now and go through these 4 terms and define them as best as you can. Make sure that you use words that you understand. Don't just take things from the internet or from your textbook and not understand any of the wording. Try to put it into your own words if possible, and we will talk about this in class, all 4 of these words. One of the main words of this standard is a rational number, and I'll actually define that one for you. It's a number that can be written as a quotient of 2 integers. Whole numbers and integers are part of the set of rational numbers. And what I've done here is I've given you a little picture. I took this right from the book, and it explains what rational numbers are. And basically a rational number contains integers and whole numbers, which we've learned in the past, but we will be reviewing this a little bit in the upcoming lesson here. All right, so we're going to practice writing a number as a quotient of 2 integers. I believe quotient is another one of your words, and that means division. So we are going to start here with the division sign, also called a fraction bar. And the number 24 can be written in a different way that still means 24. And what are we going to put that over? We're going to put that over 1. So 24 divided by 1 is still 24, and it is written as a quotient. And if we wanted to get more into the actual definition of a rational number, you would say, okay, let's take the number in front of us and put it in the form of A over B, where they're different numbers, and B cannot be equal to 0. You don't want the bottom to ever be 0. That is called an undefined number, and we don't want to have that in the denominator. Okay, the next problem over is a decimal, and we can take that decimal and write it as a quotient also. So we're going to start here with our fraction bar, and we're going to read that as the 87 hundredths. Okay, we know that because the 8 is in the tenths position, the 7 is in the hundredths position, so we read that as 87 hundredths, and we can write that out as 87 over 100, and then check to make sure that you are in simplified or reduced form, and we are. Okay, the final problem on this page is a mixed number, and it happens to be negative, which is okay. They want us to write it as a quotient of 2 integers, and right now I see up on the board 3 integers, so we're going to have to change that a little bit. If you recall taking a mixed number and turning it into an improper fraction, we take the whole number 2, multiply it by your denominator, which is 7. You're going to add your numerator, which was 3, and put it all over your denominator. We're going to keep that denominator the same, and recall that it is also still negative. So let's work this out. We have negative in the numerator. We're going to go 2 times 7 is 14. 14 plus 3 is 17. 17 over 7. Please make a special note in your journals that the problem started off with the negative sign in the middle of our fraction bar. You can also write it 2 different ways that all mean negative 17 sevenths. We can have negative 17 in the top, or we can also have the negative in the bottom. So we have it in the middle, we have it in the top, or we have it in the bottom. And again, they all mean negative 2 3/7 or improper fraction, negative 17/7. All right, moving along according to the standard. Again, my job is to just make sure that you understand all those fancy words that they're using. Up on the top here in black writing, it says, understand informally that every number has a decimal expansion. For rational numbers, show that the decimal expansion repeats eventually. So there's a couple of things that can happen with a rational number. A rational number, again, is written as a over b with b equaling 0, or not equaling 0, sorry. And upon division, the division will either have a terminating decimal or a repeating decimal. Let's see what we have here in front of us. Okay, the only way to find out right now is to take our fraction and do our long division without a calculator. It's always the top, 1, divided by the bottom, which is 5. That's your denominator. And we find out that 5 cannot go into 1. So what we have to do here is we have to add a decimal, add a 0, bring the decimal straight up. So we know that 5 goes into 1 0 times. It doesn't happen, but 5 can go into 10 2 times. 2 multiplied by your 5. This is your old multiplication and division from elementary, and we subtract our two numbers, and it shows that we have a remainder of 0, nothing left over, so our division is complete, and our rational number 1/5 is actually equal to the decimal of 0.2, which we call it 2/10. All right, the second one is a mixed number. I made it negative on purpose just so you're not afraid of these negatives and you're not afraid of these fractions and mixed numbers. We're going to take it step by step. I see here that I'm going to have a -3 and a decimal. Now the decimal is there to hold the place and wait for the fraction to tell us what the decimal portion of this mixed number is going to be. So let's go do our division of the fraction underneath. Again, remember, it's going to be the top divided by the bottom, which is the numerator, divided by the denominator. Again, we know that 25 cannot go into 4, so we add a decimal and a 0, bring the decimal straight up. 25 cannot go into 4, so 0 times. 25 goes into 40 one time, so we're going to have a remainder here. 1 times 25 is 25. We subtract. Do our little cancel here for you. 10 minus 5 is 5. 3 minus 2 is 1. And again, we look down here. 25 cannot go into 15, so we could always add a 0 and bring it down. Extend this out a little bit. And 25 goes into 150. Think about money. How many times does a quarter go into $1.50? And that's going to be 6 times. 6 times 5 is 30. 6 times 2 is 12, plus 3 is 15. Subtract, and we have a remainder of 0. So this is the decimal portion of this mixed number, so we read it as -3 and 16/100. All right, the next part, again, I took the wording right from the standard up at the top there. It says, understand informally that every number has a decimal expansion for rational numbers. So again, we're doing the same thing that we did last time, except it looks like they started us in a decimal form, and our job is to now take the decimal and write it as a fraction, or maybe in the case on the bottom there, mixed number. All right, so we read this as 5 is in the tenths, 4 is in the hundredths, so we read this as -54 hundredths. That is written as a rational number. However, we have to check to make sure that it's simplified, and it is not in simplest form. So we're going to reduce this. 2 goes into 54 27 times, and 2 goes into 20 50 times. And make sure we apply our negative to our answer. And remember, since we have one negative there, we can have it right here in the middle. We can have it written in the top, or we can have it written in the bottom. And all three of these could be your answer. Bottom one reads as a mixed number, 7 6/10, 7.6, as you like to say it. I don't like to say it that way, but 7 6/10. Let's just look at it as a mixed number. All right. Well, I'm looking at 6/10, and I think you see it also. We need to simplify that fraction. So what goes into 6 and 10? Well, 2 goes in 3 times, and 2 goes into 10 5 times with our 7. And let's check out our directions. Practice writing a fraction or a decimal as a mixed number. Okay, I think we're covered there. So we took our mixed number and simplified it here at the end, and that matches up with our decimal that we began with. Last page. This is the most difficult page. Again, taking the wording right from the standard. Convert a decimal expansion which repeats eventually into a rational number. All right, so I see that the 3 here is repeating. And what that looks like as a repeating decimal is the 3 that just keeps going on and on and on. And there's a certain way the book likes to do it. I've seen it online different ways. I personally like the way the book does it too. I set this given number equal to x. I'll just put 4 3s after the decimal. And to get rid of this expansion, this repeated decimal, what they do is they multiply the given number by 10. So if I go 10 times x, I'm going to have to multiply this by 10. And that's going to move the decimal 1 time over. Anytime you multiply by 10, you move the decimal 1 time to the right. So now it's going to look like this. I'll just put 4 3s again. I could keep going if I wanted to. And here we're going to subtract them. It's just part of the process. 10x minus 1x is equal to 9x. 3 minus 0 is 3. And then these are all going to cancel to zeros if you did your subtraction. All right, so 9x is equal to 3. We're going to divide both sides by 9. It's part of algebra. I think you learned this last year. I hope you learned it last year. So x is equal to 3/9, which can be reduced to 1/3. So the rational number, look, is the fraction called 1/3 to this repeating decimal. Okay, the last problem over here, it looks like we have a 12 that's repeating. So it's going to be 0.121212, etc. And let's go to our process here. Let's set x equal to that. 1 2 1 2, we'll do 4 numbers. And since we want to get rid of that repeating 12, when we move this over 2 times, we're actually not multiplying by 10, but we're multiplying by 2 zeros, which is 100. X is equal to 12. And again, we'll just write a couple of the repetitions down, and now we subtract. So 99x is equal to 12. These all cancel to zeros if you subtracted them. And let's divide by 99, which is touching the x, both sides. And x is equal to 12/99. And we know that we can reduce that because 3 goes into both of them. 4 times here and 33 times there, and we're in final fraction form. So 4/33, 4/33 is the fraction form of this repetitive decimal of 12 repeating. All right, I hope that was informational for you. Again, that's not the be-all, end-all of what we're going to be talking about in the standard. We're going to be doing some more things in the classroom. We'll be writing some items in your journal. Tonight, like I said before, I'd like you to define the given terms on that second page of the flip chart. And then I'd like you to write a few sentences on what you learned from this video. And I'll see you all in class.